Welcome back, my dear students. Welcome back. Very happy good evening to all of you, beta. Very happy good evening. Shiva, Tarun, Anushka Viswas, Ayush, Pragya Singh, Susmit Nandi, and all. Confirm me, beta. Audio, video crystal clear to all of you. We can proceed. Okay, beta. Fantastic. So now we are in lecture number 15. Kinetics of Chemical Reaction Part 5. As you all know, this is Gaurav Srivastav sir from Engineering Institute of India with 14 plus years of teaching experience as GATE Chemical Engineering author, educator, multiple GATE top ranks like 2025 AIR 43. So without any delay, beta, I'm going to start with some PYQs. So tell me, beta, everyone, ready for PYQs? Just tell me yes, sir, so that we can start, beta. Come on, everyone, please tell me. Everyone ready, beta? Yes, sir. Okay. So this is today's problem number one. That is problem 61. Gate Chemical Engineering 1992. If this question they are going to ask this time, then 2 marks question. Previously, 5 marks, 6 marks questions are also there. So consider the set of elementary reactions A is forming B, A plus B forming C, A plus D forming 2E. At a time t is equals to 0, a batch reactor is filled with a mixture of A and D. What is the relation between the concentration of B and D after a time t? So please make this relation, and after completion, final, just no need to send me complete derivation. Just send me your final expression. Okay? Just send me your final expression. Problem is very, very easy. Just you have to write respective rate expressions for different components that is required in order to get that relation. Come on, beta. Final 2 minute timer started. Still waiting for your answer. No, beta, Anushka. Not correct. क्या दास? Wait, beta. Unable to see your message. Okay, beta, time up. Not correct, beta. Kyadas, your answer is also not correct. It's concentration of B and D after time t. Anyone wants more time, beta? Tell me, everyone. और time चाहिए और solution from my side. More time you need. You want? Okay. No, beta. Karunya Mohan, not correct. Okay, more time. Anushka Viswas. Your answer is also. I don't think so. Ayush. I have to check it again. Hmm, not correct, beta. Answer सही नहीं है बेटा आयुष. A silly mistake done by you. Just see my approach in yesterday's problem, beta. Okay, Ayush. Mehna. Let me check, beta. Hmm, steps are DCB minus RB. Yeah, equation is correct, beta. Just solve this equation, beta. मेहना, इक्वेशन को सॉल्व करिए. Try, beta, try. Just solve that equation. Okay, beta, final 2 minute. I can't give you more than 2 minutes from now. I checked your copies, beta, but still, few students' intermediate terms are correct, but at the end of your solution, you had done some silly mistake, beta. So just check that silly mistake and do it again. Still, you have approximately 1.5 minute. One more answer I got. It's from Sushmit Nandi. This time Sushmit Nandi, I think your answer is correct. Sushmit, congratulations beta. I think your answer is correct. But not sure because answer is not written by me. I have to solve this. But I remember ऐसा ही कुछ आंसर आया था. ऐसा ही कुछ इसका आया था. ऐसा ही है कुछ. Okay, so congratulations beta Susmit because your steps are correct. If some plus minus mistake is there, then just compare with my solution beta. Okay. छोटा छोटा लिखियो ना तो I feel difficulty while checking. DCB. Okay. Very good. Very good. Till now, no. Okay. सही है बेटा आपका. Very good. Now just compare with my solution again. Final expression एक बार compare कर लेना क्योंकि कोई mistake ऐसे तो नहीं दिख रही but plus minus कुछ किए होगे तो वो बहुत अच्छे से check नहीं किया हमने. ठीक है? But I think your answer is correct. Now just focus here, my dear students. Problem is very very easy. One more answer coming from Ayush. Ayush, uh, maybe your answer is correct, but Ayush, let me check. Okay. Okay, अब तो आंसर ही आंसर आ रहा भाई. अनुष्का विश्वास. Anushka beta, your answer is not correct. Clearly I can see mistake. One more answer. Very good yaar. Mehna, your answer is looks like correct, but wait for final solution by me. Just compare final option. Then at the end of solution, tell me कि आप सही थे कि नहीं सही थे. Your answer was correct or not correct. So consider the set of elementary reactions. What is the meaning of elementary reactions? Elementary reactions, the reactions whose rate expressions follows stoichiometry. At time t is equals to 0, a batch reactor is filled with a mixture of A and D. What does it mean? That means the initial concentration of Ca is Ca naught and Cd is Cd naught. And these two clearly not equal to 0 because you are feeding. But if you are feeding only A and D, that means Cb naught, Cc naught, and CE naught if required, and if you are writing anywhere, then clearly these are 0 because only you are feeding mixture of A and D. Okay. Now what is the relation between the concentration of B and D after time t? Okay, so you have to make relation between B and D. So because B here clearly you can see it is not present in feed, so you have to write net formation of B, that is plus RB. So DCB, just as you had seen yesterday, I had make many relations like A and B, A and C relations, B and C relation, or you can say R and S relation. Similarly, here also I am going to do the same thing. So dCB by dt, clearly you can see better. The B is going to form by this reaction, but at the same time B is also going to consumed by this reaction. So net formation is form minus consumed. So here formation rate is K1Ca because elementary reaction. So clearly I can write K1Ca. And now is disappearance by this reaction. So I can write K2CaCb. Okay, so now this is my beautiful equation number 1. Next asked after B, D. You have to make relation between B and D. So now please write the same expression for D. So D here clearly your reactant, so you can write the net disappearance of D, that is minus D Cd upon dt. From A, no D is there, Here also no D is there, only D is present here. So you can write K3CaCd because the reaction is elementary one. So K3CaCd. So this is your reaction number 2. Now you know how to make relations here. सभी को पता है. So just you have to divide these two equations. So divide these two equations. Equation 1 divided by equation 2. What will we get? Now you can write here, my dear students. dCb by dt will be cancelled. So directly I am writing, because you all know we discussed it yesterday. So plus dCb by minus dCd left here. Okay. And in right hand side, my dear students, K1Ca minus K2CaCb, K1Ca minus K2Ca, K2CaCb. One more answer coming from this time Ayush done again. I think your answer is correct, but Ayush, just plus minus mistake you had done or not. Uh, After comparing with my solution, my final answer, then tell me. And whole upon it's K3CaCd. So K3CaCd. Now clearly you can see beta CaC everywhere. This dt is also there beta. If you are asking sir where is dt, dt is also there. Don't worry. No, just take common Ca from here and you can cut from here. Dt also cancelled here. So what will we get, my dear students? dCb upon dCd. ये बी और डी एक जैसा बन जाता है, माइनस, एंड दैट बिकम्स इक्वल्स टू K1 minus K2Cb and whole upon K3CD. Now clearly first order linear differential equation of variable separable type, just like dy by dx. So now further solving I can write it as dCb and upon, this is the function of v, so I can write here K1 minus K2Cb, and that becomes equals to beta dCd upon K3CD. Now just integrate. Now you have to take limit. Limit is very, very important. So is there any initial b was there? No. Initially just you are finding a and d. So b is not there. So initial limit is 0. At time t is equal to 0, cb is 0. But cd is cd naught. Limit is very, very important. After time t, its concentration is cb and its concentration is cd. Now just you have to solve this. You will get your final answer. One more answer coming from this time again Shiva Tarun. Solved very good, beta Shiva Tarun. I think your answer is correct. So just solve this beta. So minus 1 upon. First you can write here ln of K1 minus K2 CB. Then K1 differentiation is 0 and minus K2 CB is minus K2. So here also you will get minus K2, so minus minus plus, and it is K2. And that becomes equals to 1 by K3 is constant 1, and here you can write ln of CD. Now limit, here limit is 0 to CB and here limit is CD not to CD. So upper limit is going to give you same thing. K2 you can write on right hand side, so it is ln of K1 minus K2 CB, and lower limit 0, 0 will be make it 0, so minus ln of K1 log a minus log b, so I can write here upon K1, and that becomes equals to K2 by K3 and ln of CD minus ln of CD naught, so I can write ln of CD upon CD naught. Now further solving, my dear students, I can write ln of K1 minus K2 CB and whole upon K1, and that becomes equals to ln of CD upon CD naught, and it's raised to power K2 by K3. Ln cancelled. So finally you can write K1 minus K2 CB whole upon K1, and that becomes equals to CD upon CD naught raised to power K2 by K3. Okay, now please tell me. क्या आपने यही प्राप्त किया था? Are you also getting the same to same expression, my dear students? This is your answer. So let me check. Yeah, Shiva Tarun also same answer, but one step above. This one is given by most of the students, but still you can solve it. Okay, थोड़ा और इसे छोटा कर सकते हो. बट बेटा शिवा तरुण, हमने कुछ गलत किया या आपने गलत किया यार? माइनस आपका कहाँ गायब हो गया? शिवा तरुण, जस्ट चेक योर माइनस बेटा, because other students also getting same. This one is K3 na, K3 K3 K3, yeah, K3 K2 by K3. Shiva Tarun, yeah. Tell me beta, I had made any minus mistake or you had done mistake? Because most of the students also getting same thing as I got. यही तो आ रहा है सभी का, ये वाला equation, this equation you got. Hmm? No mistake from your side. No mistake, sir. Okay, that means my expression is correct. Okay, very good, beta. That means you made some minus mistake only. Tell me, the problem is very very easy. आपका सही है सर. ओके बेटा शान मुखर्जी. So problem is very very easy ना. समझ गए everyone? Tell me, my dear students, is it crystal clear? No doubts at all? Now you can solve this type of problem. Can we proceed? Can we proceed, my dear students? चलो बहुत अच्छे, वेरी गुड. चलो बहुत अच्छा, वेरी गुड बेटा. So see, GATE 1993 2 mark question. Solve this one, my dear students. Two-minute timer started, my dear students. No personal talk message beta, just comment your answer, my dear students. Okay, don't waste time during other typing. Solve this and tell me answer beta. Last 1 minute beta. Problem is very very easy. 2A is forming R, 2R is forming S. The number of moles of S present when the number of moles of A and R is 0.3 and 0.5 respectively. Initially 2 moles of A are only present is. करो करो जल्दी जल्दी सॉल्व करो बेटा. Just send me your answer. No need to share any pic now for this question. Just share A, B, C, D. Which one is correct? Okay, Shian Mukherjee and Ayush got B. Very good, beta. Time up. Still, you can take few more time. Very good, beta Shian. Only two students able to solve. Sushil and unable to solve. Anyone wants more time or solution from my side? Very good. Devashak Nutri also getting B. Very good. Tell me what anyone wants more time. Kiadas, very good, very good. Kiadas also getting B. Okay, okay. Now answer is coming. Karunya Mohan B. Very good. Very good. Anushka Viswas more time. ले लो भाई ले लो more time कोई दिक्कत नहीं because when you are going to get answer without my help then definitely it will boost up your confidence but not more than this final timer. Done beta Anushka? Very good. Anushka also get thing B. Okay, so I'm stopping timer because only one student asked for extra time and got correct answer. Very good. I'm very happy, beta. Very happy. So for multiple reactions, now see my approach. 2A is forming R. This is our reaction number 1. 2A is forming R. And the second reaction is 2R is forming yes. So the number of moles of yes present when the number of moles of A and R is zero point 0.3 and zero point 0.5. Okay. So clearly here A fed its value 2 moles written. A reacted if you want to write beta. So A reacted is clearly you can see number of moles of A zero point 0.3 left. That means 1.7 reacted at that time t. And moles of yes formed. Moles of yes, not yes. Wait. Moles of R. Moles of R formed. So you clearly mentioned R is zero point 0.5. But wait, R is forming and disappearing both. That means this is net amount of formation of your R. Okay, now just simple thing. You can use stoichiometry beta. 1.7 reacted. So it is going to give you how much R? 2 will give you 1 R. So 1.7 mole will give you 0.85 R. But R is only zero point 0.5. So R reacted by reaction number 2 is how much? Clearly 0.85 formed, but only you can see zero point 0.5 left. That means from next reaction 0.35 moles are reacted. So 1 is going to give you zero point 0.5, 2 is 1, so 1 zero point 0.5. So 0.35 is going to give you 0.35 divided by 2. So as formed will be 0.35 by 2. After solving it will come beta 0.175. Tell me beta, everyone please. Is it crystal clear to all of you? Is it crystal clear? Can we proceed my dear students? No doubts now, very easy. Crystal clear sir, I was thinking in terms of rate equations. But every time no need to think by rate expressions. Sometimes just by fundamentals you can get a correct answer beta. That's why I told you see my approach. Okay beta Shushmit Nandi? Okay, so see, next one, this one is very easy. For this, no extra time is available. Only maximum this 2 minute timer is available for you. Only this 2 minute timer is available for you. Come on, everyone. Last 1 minute, beta. Very good. So, still 20 seconds left, but I don't think so that anyone wants more time. Ayush, Shayan, Sai Kumar, Divashak Nihotri, Shiva Tarun, Sushmit Nandi and all. Very good, beta. Fantastic, Prashant. बहुत अच्छे बेटा. So the conversion for second order irreversible reaction constant volume A is forming B in batch mode. Here reaction rate constant written as K2 and clearly it is second order, so you can write Ra, only one reactant is there. So for second order it should be K2 Ca square, and in place of this you can write minus dCA by dt, and just we solve it. So I'm not going to kill time here. So after solution you got Kca naught T upon 1 plus Kca naught T. Everyone I hope remember for second order reaction that X is equals to this one. This time K2 is there, so just write K2 K2. After solving this, after putting limit, you will get this one. So clearly B is the right answer. Very easy. GATE 2001, 1 mark question. Okay, so this one is also very easy. Please tell me what everyone from auto catalytic reaction. Which one is correct? A, B, C, D. Very good, Ayush. Very good, Shiva Tarun. Everyone know. This time my dear student, this is versus concentration. आपने देखा नहीं लग रहा है. This is versus concentration, not versus time. लग गई लंका। हम्म। क्या सही है? दिस इज आर्य वर्सेस कंसंट्रेशन, बी केयरफुल। If you want to change, you can change. But think again, still you have 1 minute. हाँ सर, जेल में फंस गया लग रहा है। Now C. Oh my God, what is this? Previously A, and now C, 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 C. What is this? Hmm? Change. इतनी तेजी से सी ए आंसर आया है यार, मतलब ए डन 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 डन. But now you are changing C. Tell me, any other student wants to convert? आयुष, शिवा, तरुण, कियादा, सुसुदंडी, महना, शियान मुखर्जी, करुण्या, देवर्षक न्युति, प्रज्ञा सिंह, A. Anushka Viswas, Karunya, and now Shian Mukherjee also changes answer to C. Any more comments? Tell me, beta. Mahalakshmi is also there now. And Mahalakshmi telling sir A. Sai Kumar, Ayush A. Let's wait for answer, sir. Still doing. Done, sir. Anushka Viswas changes from C to A now. So, my dear students, the right answer here is option A. ऑप्शन ए इज करेक्ट बेटा, सी करेक्ट नहीं है. दोज हु चेंज्ड नॉट करेक्ट बेटा. ओके श्यान मुखर्जी, गॉट इट बेटा. ए इज द राइट आंसर एंड दिस इज द प्रोग्रेस ऑफ रिएक्शन. प्रोग्रेस ऑफ reaction, and this is the chart when no R in feed. When no R in feed, here written in adequate reaction is conducted isothermal batch reactor with a small initial concentration of R. So small initial, that's why see it is little bit not at zero, but it is negligible amount here. Assume that the order of reaction with respect to both reactants is positive. The rate of reaction versus concentration proceeds. Clearly the concentration when decreases, my dear students. Initially the rate is less, but now Ca is decreasing but rate is increasing. But after some point, again when Ca becomes equals to Cr, further decrease in Ca and increase in Cr, net effect is decrease in rate of reaction. So beta A is the right answer. You know, the same graph I can make like this. See, one graph is like this you had seen, and the second one, this can be like this. If this is the graph starting point this one, it shows, suppose they are asking in examination beta, so it shows that some R is in feed, some R is in feed. So a starting rate of reaction value is higher than this comparison to no R in feed. No R in feed. Okay? Is it crystal clear to all of you, beta? Can we proceed? ये तो हो ही नहीं सकता ना बेटा. According to this one, clearly it shows that whenever concentration decreases for A, rate decreases continuously. But it is not the case, na yaar beta. You know, autocatalytic reaction, initially rate increases, then further decreases. Initially increases due to formation of that product, acts as a catalyst, and then rate decreases due to the concentration of reactant is going to decrease beyond a limit. Is it crystal clear to all of you, beta? Tell me everyone, can we proceed? क्या हम आगे बढ़ सकते हैं? No doubts? Crystal clear, sir. Okay, okay, very good, very good. Okay, so few more graphs I want to discuss with you, beta, about that parallel reaction. Just focus here. So, graphs for parallel reaction. Graphs for parallel reaction. A is forming R, is forming S, K1, K2, and both order 1, order 1. Okay, both for first order reaction. Now, just focus here, beta. Just focus here. I am going to draw here few graphs. Just see one by one every graph, so that you can make a graph for any type of given reaction mechanism. Very, very important. These graphs are very, very important. So if any doubt, immediately ask me. Now see. The first graph that I am going to make between concentration, this time it is a time, this time is time, here also time, here also time, here also time, here also time, and this side concentration, this side concentration, here also concentration, here also concentration, here also concentration, here also concentration. So everywhere concentration is there. Whose concentration? It may be A, it may be R, it may be S. That means on the same graph you are going to make how concentration of A, R, S going to change with time. Now I am giving you, my dear students, the case number 1. So my dear students, here in this case I am telling you that K1 is equals to K2. Okay, here I am telling you that K1 is greater than K2. Here I am telling you that no, K2 is greater than K1. So can you make a graph for A, R and S? How concentration of these A, R, S is going to change with time? How concentration of A, R and S going to change with time? After plotting, just write done in comment section, beta. First order, first order. Done? Still doing? Okay. So if K1 is equals to K2, see beta, the concentration of A, if this is the initial concentration of A, Ca naught, okay, and I am assuming that there is no R and S present in feed, okay. So A graph will go like this, just you had seen exponential decrease graph yesterday, and R and S both formation rate will remain same. This is R, this is S. This is for CR as well as CS, and this is for CA. But if K1 is more, that means every time the formation of R, rate of formation of R is more than S, A is still same in similar manner. This is CA. But now R and S follow different path. Like this is one and this is second one. So clearly if K1 is more, that means the formation of R is more. So here you can write CR, here you can write CS. Now similarly here, my dear students, A always decreasing with respect to time. But when you are going to form graph for R and yes, so in this case beta you can see K2 is more, that means formation of yes is more because both are first order. So K2CA, K1CA. So K2CA is more. So clearly this time when you are going to plot, you will get again two different graphs where this time because K2 is more, so it will be CS and this will be CR. I hope everyone is crystal clear. सभी को clear होगा. Now here, suppose the same reaction I am showing like this in examination. A is forming R, A is forming yes, 1, 10. A is forming R, A is forming yes, and this time 1, 2. Okay. And we are mentioning that order with respect to order is 1 with respect to R and S. 1 and 1 with respect to R and S. In both cases, order is 1. That means whenever you are seeing 1 and 10 or 1 or 2 here, these are is actually the value of reaction rate constant. That if one reaction rate constant is 1, then the other one is 10. Okay, so in examination, if they are mentioning like 1 or 10 here, so don't take it like order of reaction. Okay, if they are going to mention it, their usual meaning is the reaction rate constant value. So can you make it again beta? क्या इसे बनाओगे क्या आप? Just draw it beta. Just draw it. Here, if this is your A, here this will be your A. A is also affected beta. हाँ हमको पता है आपने ऐसा नहीं किया था. You had done this mistake because here 1 and 2, here 1 and 10, 11 overall. Here 1 and 2, 3 overall. So this is for A comparison. Okay. Now clearly in both cases R rate is less, so this is simply your CR, and here also this is simply your CR. But when you are seeing about yes, when you are seeing about yes, then the graph for yes here you have to make like this. See, it will go like this. Very fast increase, and here little bit like this. Okay, that means the space in your examination during match the column, maybe you have to check this space beta. So clearly you can see when the value of reaction rate constant are too far from each other, then definitely the concentration always more difference between the graph. and if they are closely to each other, then definitely the graph, both graph will be close to each other. So I hope that this concept is crystal clear to all of you, and now any type of graph you are able to make for this type of reaction. Soon I will also make a few more graphs when reversible, you will see reversible reactions kinetics. Okay, so tell me better, this one is crystal clear, can we proceed? ये सभी को clear है ना? This one is done, crystal clear. Okay, very good. Sir, please repeat fourth and fifth graph, Prashant. But a fourth and fifth graph is very easy. Here, just I told you that the value of this is the K2. Here, K2 is much greater than K1. And here, just K2 is little bit greater than K1, Prashant. So, if much greater than that means the rate of formation of S is much higher in comparison to R. So, see, rate of very fast increment in the concentration of R in comparison to this R. The rate of rate of formation of S is very high. But here the rate of formation of S and R is not too far from each other. Okay, is it crystal clear, beta? Just a typical graph I made here, just in order to show you the distance between their formation graphs. If reaction rate constant is more, very more, that means their formation rate is also very more, very high. Okay, Prashant? Sir, can you tell me CA curve for fourth and fifth case? Beta mehna see. Here the overall value that given on these graphs, like here telling 1, here telling 10, 110. What does it mean? That means A here, suppose after in every second, suppose I am telling you that 1 mole of A is going to converted into this R. Okay, 1 mole is going to converted into this R. Okay, then same time 10 mole is going to convert it into S. So that means in 1 second 11 moles of A is going to consume. But here in 1 second 1 and 2 3 moles are going to consume. So faster consumption na, rate of net rate of disappearance of A is more here na. So it will decrease in faster manner in comparison to this one na beta. Like suppose you are writing expression, see here, see you are writing expression like minus RA is equals to K1CA plus K2CA. In one case, you are writing like K1 value is C, how much? It's 1 and 10. So CA plus 10CA. So total rate of disappearance is 11CA. And in second case, this is how much? See, it's 1 and 2. So right here, 1 that means 1CA and plus 2CA. See, it's 3CA. So see beta, rate of disappearance is much higher now. 3CA. So here this is your rate of disappearance for second graph, and this is the rate of disappearance for first graph. Are you getting my words, beta? Mehna, tell me beta, is it crystal clear now? So faster decrement na, faster rate of disappearance. If faster C, very rapidly decrease in concentration of A because A is reactant one. And here little bit A decreases in slower manner. Like in the same time, if you are going to check, see here concentration of A is this one, and here in the same time if you are going to check the concentration of A, see it is only and only this one. Okay, yes sir, getting very good. So no doubts, can we proceed? सभी लोग बताएंगे बेटा, किसी को कोई डाउट नहीं है, आसान है, crystal clear sir. Okay, so see one beautiful PYQ asked, very easy, it's very easy. Tell me which one is correct. No timer required for this question. Tell me, everyone, please. Which one is correct? Very good. क्या बात है? So clearly see. And don't worry, I will also show how the graphs of this A is forming R is forming A, and A is forming S, and this one. Okay, how the graph of these two are going to form. But this graph you can make on the same diagram like this. Okay, this is for option D. This is for option D. If option D is correct, then this is for R and this is for S. For option D. Okay, clear to all of you, beta? सभी लोग को clear? Done? चलो बहुत अच्छे, very good. That means now we can start next topic. So next topic is beta series reaction. Now we are going to see kinetics of series reaction. So please everyone write series reactions. Series reaction. And everyone know basics of series reaction. That means in order to get final product, some intermediate formed first. So simple series reaction you can write like A is forming R is forming S. Okay, where here reaction rate constant is K1 and here reaction rate constant is K2. And both places the order is first. Sir, is it possible that order can be changed? Yes, beta, you can do as your homework if you want. Like A is forming R is forming yes. Okay, like here zero order reaction, here first order reaction, and maybe it can be done as A is forming R is forming S, here first order, here zero order. Or it can be done as A is forming R is forming S and zero order. Okay, second order is also possible, second order is also possible, but that will be very very difficult and the chances are just like 0% in examination that they can ask, nearby 0%. But still if they are going to ask, no need to worry, you are able to solve it in similar manner. So if you want you can do this as your homework. Okay, and if you want to discuss with me, you can ask me in doubt clearing session, I will derive that one for you. In few cases you can stuck at some intermediate expression, but don't worry, that will be your final answer in your examination. They're not going to ask you to solve that equation, they will give you that equation, which one of the following equation follows that chemical reaction. So just take on that one. Okay, if you are stucking in anyone, क्योंकि इन तीनों में से yes everyone, all these types reactions solved by me, and out of these three in one case you will stuck on a equation, but don't worry, that is your final expression. For that you need trial and error, so trial and error is not available for you. Okay, so I am going to discuss the main conventional, this one, and similarly you can derive for these all. Here my dear students, if I am going to write the rate of disappearance of a RA, then it can be written as, clearly these all things are also we are discussing same to same. Epsilon A is equals to 0, clearly A is forming R and R is forming S, it is not 2R. Okay, and so minus RA can be written as minus dCA by dt directly, dCA by dt, and clearly its disappearance is just by K1CA. Now next one, rate of formation of R, it can be written as how, then rate of formation of S, it can be written as how. So please write it and write done in comment section one more time, beta. Just write done in comment section. चलो बहुत अच्छे, very good. So what is R? A rate of appearance or formation of R. So R, that means plus dCr by dt, and it can be written as R is formed by K1Ca, but at the same time it is going to disappear by K2Cr, and the rate of formation of S can be written as dCs by dt, and clearly it is going to formed only and only by the second path, that is K2Cr. चलो बहुत अच्छे, very good. So just to mention them like equation number 1, equation number 2, equation number 3. Now here one beautiful graph you can make. So I am showing you one conventional graph. See this one. Here again I am writing same to same concentration, and here I am writing time t. Okay, so clearly whenever you are going to plot for a is going to decrease exponentially. You have already solved this one. Okay, I will solve it again, don't worry. But when you are going to write for r and s, can you make a graph for me for r and s beta? r और s के लिए एक बार आप जरा ग्राफ बनाओगे क्या? Please everyone make it for r and s. For r and s, jaldi, don't take too much time. Don't take too much time. Just draw it immediately and tell me. And as I am mentioning that CR naught and CS naught both are not present in your feed. That is, feed is pure A. Feed is pure A. हो गया बेटा? For R and yes. Very good, Ayush. Ayush, your a slope and I think slope is different. Pragya, very good. Sai Kumar, very good. Sai Kumar, beta, your graph is not correct because concentration of R is going up to CA. That is not good, na? Huh? Yes is going like this, or it is going like this. Now, see here. The graph for yes will be like this, and it can go up to this max, and the formation of R will be like this. Because yes is forming initially at a slower rate, and then its rate will be increases because initially the R amount is very less, then the amount of R will be increases with respect to time. Okay, so the main thing that you can see in this diagram that R is going to show you some maxima, that is CR max. The concentration of R, you can see at some point of time is at max. And if something is happening like this, then beta you have to calculate that concentration. So this is our one work in this series reaction, so that we have to find how much what is the value of CR max. So our equation who is going to give us the value of CR max and at what time it is going to get. So that time is T and this time is written as T max. T max is not max time. Here T max is not the max time. What is T max here? See, what is T max here? T max is not the max time. T max is the time at which concentration of R is maximum. Concentration of R is maximum. Okay, so that means these two works we have to do here, and also we have to do a work, more work, that simple conventional work, that we have to form a equations who is going to show us the concentration of A, R and S, how changed with time, with respect to time, how concentration of A, R, S changes with respect to time. And the second thing, what is the max concentration of R? And the third thing, at what time we are going to get the max concentration of R? Okay, so that means mainly two works we have to do, one conventional thing and the second one for CR max, the value of CR max and the time at which CR max happens. Okay, so please tell me everyone, is it crystal clear? Can we proceed with our derivation beta? फटाफट बोलते रहो बेटा. Everyone please tell me, so that you can feel just like offline class beta. Everyone please tell me, is it clear to all of you? Can we proceed, my dear students? Done. Derivation, we can start derivation. Crystal clear, sir? Okay, okay. So the variation of A with respect to time is very easy, so that you can make by equation number 1. What is equation number 1? Very easy. It's minus dCA by dt, and that becomes equals to K1 CA. Now if you are going to solve, already solved, so dCA by dCA by C is equals to K1 dt. Just take limit here. Initially the A is CA naught, at time 0, at time t it is CA. After solving, you can write it as putting limit minus ln of CA by CA naught, that becomes equals to K1 t. This is your final expression. Further solving, this equation can be written as CA is equals to CA naught e raised to power minus K1 t, and these all derivations already done by you, graphs already plotted by you. Graphs already plotted by you. If you want to plot it again, you can plot here. It's very easy. It's very easy. If this side you are writing CA, if this side you are writing time t. So clearly the concentration of A is going to decrease with respect to time, exponential decrease. And when time is 0, so e raised to power minus 0 or 0 will give you 1, CA will be CA naught. So graph started from CA naught. Its slope initially more slope, then less slope, then less slope. So you can write here slope decreases. Slope decreases with time. With time. Slope decreases with time. Okay, if this graph we are if somewhere you are getting this type of graph, so here also slope decreases with time. If you are getting this type of graph, it shows you slope increases with respect to time. So here slope decreases with respect to time. See, here slope is this one, here slope is this one. Okay, is it crystal clear to all of you beta? Can we proceed? Very easy. Sir, at CR max will the three lines intersect beta? CR max, where it is going to occur, it is strongly going to depend upon the value of K1 and K2. So you can't say exact position of CR max. Okay, it can be after this intersection, it can be before this intersection. So it is clearly dependent upon K1 and K2 value. K1 and K2 value. Is it clear, Beta Mahalakshmi? So I hope concentration of A is crystal clear to all of you. Now we are going to discuss for R. Okay, sir. Very good, beta. So here for A. This one was for A. For A. Now for R, you have to do more work. For R, you have to do more work यार. आपको इसके लिए थोड़ा ज़्यादा काम करना होगा. In CS curve, slope will decrease with time. No, beta, it is increasing with respect to time, Ayush. Slope of S is going to increase with respect to time. S का slope यहाँ समय के साथ साथ बढ़ रहा है. Because initially very less R is there. When the amount of R is going to increase, then the rate of formation of S is also going to increase. So initially at slower rate S is going to form, but after some time the formation rate will increase. Okay, sir. Very good. So, and this is just a typical graph. Graph may slightly differ from cases to cases, and it is strongly depend upon the value of K1 and K2. And there may be some case possible where CR max is not possible. CR max is not possible. When CR max is not possible, I will tell you all cases. Don't worry. So first see this conventional case. Okay. So for R, clearly we have to take a second equation. So by equation number 2, that is plus dCr by dt, that becomes equals to K1 Ca minus K2 Cr. Oh my god. Cr is okay, but what to do with just Ca not? So how to solve it, beta? Can you tell me? Can you suggest me? इसे कैसे solve करें? How to solve it, beta? Please tell me. Bernoulli's differential Sai Kumar. Tell me, beta, everyone. Integrating factor Shiva. Tarun, very good, very good, very good. But before that, beta, you have to put na the value of Ca naught here. So you can write this equation as dCr by dt, and that becomes equals to K1. You know that Ca is Ca naught e raised to power minus K1t. C. E raised to power minus K1t and minus K2 Cr. Now, integrating factor technique you are going to use here. So you can rearrange this equation as dCr by dt plus K2 Cr, and that becomes equals to K1 Ca naught e raised to power minus K1t. So please solve this beta. इसे solve करोगे क्या आप? Everyone beta, please solve it. This is your equation number 1, 2, 3. This is your equation number 4. This is your equation number 5. And this is your equation number 6. Those who forget mathematics, don't worry. Don't worry. Now, just focus here basic mathematics. Just focus here basic mathematics. In mathematics, if you are getting somewhere equation like dy by dx plus py is equals to q, where this q is a function of only and only x. Make sure here no y term is present. Here no y term is present. So here, what is the solution? First you have to calculate integrating factor. So what is the formula for integrating factor? IF, integrating factor. E raised to power integration of p dx, because this p is also a function of x only. Are you getting my words, beta? Tell me, beta, everyone. ये पढ़ा है कि नहीं पढ़ा है? सभी को पता है? Very good. So now, after getting this integrating factor, very good, yes sir. So the solution is q into if, q into if, and that becomes equals to integration of q into if, and that becomes, sorry not q, it's y. यहाँ q क्यों लिख दिया? y into if, y into if, then integration of q into if dx and plus c. This is the solution. So please solve this, and after solving just write done in comment section बेटा everyone. सॉल्व करेंगे इसे सभी लोग. Done. By comparing these two equations, clearly in place of y we have CR, in place of x we have T, in place of P, we have just K2, and in place of Q, we have K1 Ca naught e raised to power minus K1 T. So what should be our solution now? YIF. So first we have to calculate integrating factor IF for our case. So integration of exponential of integration of P dx. So what is the value of P here? P is K2 here. So K2 and dx. So what is x here? In our case x is T. So it's dt. So it will come e raised to power K2 T. Once you got this, solution is YIF. But here we have in place of y, just see your equation beta, you have CR. So here you can write CR into IF, and that becomes equals to integration of Q into IF dx. So dx is T here plus C. So here IF is e raised to power K2T, and that becomes equals to what is Q was K1 Ca naught, K1 Ca naught e raised to power minus K1T. What is IF? IF is e raised to power K2T, and into dt plus C. Further solving, CR e raised to power K2T, that equals to K1 is constant, Ca naught is also constant, base same, so power is going to add, so K2T minus K1T. So here you can write e raised to power K2 minus K1 T, take common here, and into dt plus C. Further solving, you can write CR e raised to power K2T, that equals to K1 Ca naught, and e raised to power AX, integration is 1 by A na? So here you will get K2 minus K1 and e raised to power K2 minus K1T. अभी आप बताओगे, please tell me everyone, this integration is correct or not correct? Are you also getting same to same or different? CR e raised to power K2T. Tell me beta, are you also getting same to same? Same, sir. Very good. Now, the problem here is to obtain the value of this constant c. So we need one boundary condition and very very easy boundary condition here. Can you tell me बेटा boundary condition? Boundary condition बता सकते हो क्या? This is your equation number 7. Can you tell me बेटा boundary condition? Very good, Sushmit Nandi. So we know at time t is equals to 0, the concentration of R is 0. So equation 7 becomes, अब इक्वेशन नंबर 7 में बाउंड्री कंडीशन रखोगे, सो इक्वेशन नंबर 7 में क्या हो जाएगा, देन यू कैन राइट 0 equals to CR is 0, so left hand side will be 0 now, then K1 CA naught upon K2 minus K1, and e raised to power t is 0. 0 multiplied by anything will give you 0, and plus c. So c can be written as minus of K1 CA naught upon K2 minus K1, and e raised to power 0 is 1. So this is the value of c. This is the final value of c. You can mention it as equation number 8. So now write by equation number 8, equation 7 becomes. By equation 8, equation 7 becomes. अब इसके अंदर में पुट कर देंगे. So it can be written as now C R e raised to power K2t, and that becomes equals to K1 CA naught K1 CA naught upon K2 minus K1 e raised to power K2 minus K1t e raised to power K2 minus K1 t, and C can be written as minus K1 CA naught upon K2 minus K1. Please tell me बेटा आपको भी यही मिला? You are also getting same? Just confirm me. Are you also getting same to same? Yes, sir. Okay. Okay. Very good. So now what we can write in place of just CR? So CR can be written as C in both terms. K1 CA naught upon K2 minus K1 is common. So take it as common. And here e raised to power K2 minus K1t. So you can write K2t and e raised to power minus K1t, and the second term is just 1. And this side e raised to power K2t, you can write on this side. So it is e raised to power K2t and upon e raised to power K2t. If you are feeling any difficulty in any step, beta, feel free to ask me. So CR final expression can be written as K1 CA naught upon K2 minus K1, and here you can write K2t cancelled, so it can be written as e raised to power minus K1t and e raised to power minus K2t. This is your final expression that shows you the concentration of R with respect to time. Okay, so this is final equation for R. Final equation for CR. That is your equation number 9. Sir, do we need to remember the final expression? Yes, beta, for this case you need to remember this equation as well as CR max equation as well as T max equation. No need to remember for all, but here you need to remember because it is very very important, many times asked in examination, and in examination you can't do this derivation, it will take too much time. Okay, so you need to remember. अभी तक में ये पहली चीज आपको मिल रही है, the first thing that is little bit big, but you need to remember. आपको इसे याद करना है, you need to remember it. Okay, mostly whenever they are asking in examination, they are asking this equation like this, CR by CA naught. This ratio they are asking in examination. More chances are there. So this is K1 by K2 minus K1, and here e raised to power minus K1t e raised to power minus K2t. In this manner, mostly they are asking. The same, this equation number 9 can be written as CR by CA naught. So you need to remember it. Remember it. This one remember in blue one, standard form. Okay, हो गया बेटा सभी का? Can we proceed? Can we proceed for CR max? Done. चलो बहुत अच्छे. So now question is how to get T max and CR max. So clearly first you have to get T max, and no need to worry, just put that time here and that will clearly give you CR max. So after getting that expression, put that T value in this equation number 9. Okay. So can you suggest me how to get this T max या T max कैसे मिलेगा? Is there any technique you know? Is there any technique you know बेटा? कोई टेक्निक जानते हो क्या इसके लिए? जानते हो तो बता दो यार. Please tell me if you know the technique. Very good, Pragya. It's maxima minima. By using maxima minima. क्या बात. Fantastic. सभी को क्लियर है ना? Everyone crystal clear? So for T max, we are writing dCr by dt and putting this become equal to 0. इसे हम क्या करेंगे? इसे 0 के इक्वल कर देंगे. So further moving, it can written as d by dt of, right here expression for CR, it's K1 CA naught upon K2 minus K1, and then e raised to power minus K1t minus e raised to power minus K2t. That becomes equals to 0. So this is constant. It is going to become 0. 0 by constant will give you 0. E raised to power minus K1t differentiation. So it is minus K1 e raised to power minus K1t, and minus minus here plus k2 e raised to power minus k2t equals to 0. Further moving, you can write k1 e raised to power minus k2t equals to k2 e raised to power minus k2t. क्या ऐसे कर सकते हैं? Is it correct? So now how to solve it? Further moving, we can write this is k1 na? So e raised to power minus k1t divided by e raised to power minus k2t, and it becomes equals to k2 by k1. Or you can write e raised to power minus k1t and e raised to power plus k2t. That becomes equals to k2 by k1. Or you can write e raised to power t, you can take common, so it will come k2 minus k1t, and it becomes equals to k2 by k1. Okay, take logarithmic, so it can be written as k2 minus k1 t, and that becomes equals to ln of k2 by k1. Further moving, we can write t becomes equals to ln of k2 by k1 upon k2 minus k1. Or further moving, we can arrange it as 1 upon k2 minus k1 upon ln of k2 by k1. Beta, when a and b are there and you are going to take arithmetic mean, you have to write a plus b by 2. When you are going to take geometric mean, you can write root of a into b, square root of a and b. When you're going to take log mean, you can write a minus b upon ln of a by b. See, this is same to same now for in terms of k. So this is log mean of k now. So t is written as 1 upon k log mean. This is your final expression, and clearly it is the expression for t max. So you can write in place of t, t max. Is it crystal clear to all of you beta? फटाफट सभी लोग बताओगे. This can be written as equation number 10. बोलो बेटा, ये सभी को क्लियर है? Any doubts? No doubts? Okay. So now, सर log mean वाला explain करो क्या था बेटा. uh, this is a formula for log mean. When you want to take the log mean for a and b, just like in case of heat transfer, you're also seeing heat transfer right now. Heat transfer is also running. So T1 minus T2 upon, or delta T1 minus delta T2 upon ln of delta T1 by delta T2. This is what? This is delta T log mean na? LMTD. So same thing, log mean temperature difference. So here log mean of K you are writing. Same thing, see, 1 minus 2 or 2 minus 1. You can also write it as by multiplying minus in numerator. It will be T2 minus T1. Same to same here also it will be T2 by T1. बोलो बेटा, ये क्लियर है सब? Is it clear now? क्या दास? Just write crystal clear in comment section बेटा. ये क्लियर है क्या आपको? Is it okay? Very good, very good. Now, how to get this CR max? How to get this CR max? So for CR max, put t is equals to t max in equation number 9. We get क्या मिलेगा भाई, चलो देखते हैं. CR is equals to K1 CA naught upon K2 minus K1. E raised to power minus K1t. So e raised to power minus K1t. So t is what? T max now. K1 T max. And minus e raised to power minus K2 T max. And when you are putting t is equals to T max, this CR is now CR max. So please put the value and simplify it. After doing, just write down in comment section here. इसे करो, फटाफट करो. Do it for me. You have 2 to 4 minutes max. Just after doing, write down in comment section, waiting for your comments. Done. Waiting for some more comments. So this complex equation I hope you are getting. Hmm? Now the question is how to solve it. इसे solve कैसे करोगे? Because the final expression that you need after solving is in more simplified form. That is just CR max upon CA naught, and that becomes equals to K2 K1 by K2 raised to power K2 upon K2 minus 1. So this expression you need to remember beta. Just remember it. After solving equation number 11, we get final expression. That you need to remember beta. लेकिन ये आएगा कैसे? Can you tell me how I got this equation? Anyone got this equation by simplification? किसी का ये equation आया है क्या simplify करने पर? Just write yes sir. Okay, Shiva Tarun had sent me beautiful explanation. So K1 by K2. Oh, message deleted. If any one of you able to do this, then please tell me. Show me your explanation. Okay, again I got one picture. This is from Shiva Tarun. So K1 by K2 minus K1 e raised to power minus K1. Very good. Okay, till now it is correct. Now K1 by K2 minus K1, and here you're writing it like K2 by K1. Very good. Fantastic. Exponential term is now not there. And now you are taking common K2 by K1 raised to power minus K2 by K2 minus K1. That is second term. Okay. Very good. Now cancelled, cancelled. Very good, beta. Absolutely correct. Absolutely correct. Any more solution? किसी और ने भी किया? Waiting, beta. Send me. If done, then write yes, sir. Otherwise, write R in comment section if unable to do. Don't see explanation of other student. Okay? अपने आप से अगर कर पा रहे हो then that's good. Otherwise, write R in comment section. Main unable to do. No need to worry, beta. Other students, please tell me, beta, everyone. Please tell me, everyone. मैंने आयुष अनुष्का विश्वास किया दास unable to do. Don't worry, beta. See, very easy. Just write it again. CR max upon CA naught. And now this time got the final expression, sir. Very good, beta. Pragya. Divashak Nihotri unable to do. Don't worry, beta. Don't worry. So K1 by K2 minus K1. K1 by K2 minus K1. And here, my dear students, see. You can write K2 by K1 raised to power this all. So it can be written as E raised to power ln of K2 by K1, K2 by K1 and whole raised to power minus K1 by K2 minus K1 minus K1 by K2 minus K1 and minus E ln of, again here this is minus K2, sorry, K2 by K1 raised to power minus K2. So K2 by K1 raised to power minus K2 upon K2 minus K1. You know E raised to power ln means you can write it as 1. So again you can write it as CR max upon CA naught and that becomes equals to K1 upon K2 minus K1 and here you can write K2 by K1 whole raised to power minus K1 upon K2 minus K1 and minus K2 by K1 and whole raised to power minus K2 by K2 minus K1. Now I am going to take something common here, beta. So CR max upon CA naught that becomes equals to K1 by K2 minus K1 and here I am going to take common. Common क्या ले रहे हैं? Just second term, completely just second term. So second term is K2 by K1 and whole raised to power minus K2 by K2 minus K1. So because you are taking this common, so just write reciprocal of this here. So you can write K2 by K1 raised to power minus K1 by K2 minus K1 and into K2 by K1 reciprocal of this here. So reciprocal will write it as positive. So K2 upon K2 minus K1 and the second term is now 1 because you had already taken common. Further moving, you can write, oh wait, let me add one more slide. यहाँ तक कोई डाउट नहीं है बेटा? एवरीवन क्रिस्टल क्लियर टिल नाउ? कंफर्म में? Tell me everyone, my dear students. No doubts. So further moving, you can write CR max upon CA naught, and that becomes equals to see K2 by K1 and minus here. So you can write it like okay, don't do K2 by K1, just write it K2 by K1 and it raised to power minus K2 upon K2 minus K1, K1 by K2 minus K1, K1 by K2 minus K1, and here inside bracket beta see K2 by K1, K2 by K1, so power is going to add, so K2 minus K1, K2 minus K1 and K2 minus K1. Oh my god, that means we are getting K2 by K1 and raised to power K2 minus K1 by K2 minus K1 minus 1. That's great. So cancelled, so power is 1 now. Further moving, you can write CR max upon CA naught as this one you can write K2 by K1 and raised to power minus K2 upon K2 minus K1, and here beta K1 upon K2 minus K1, and see this one can be written as just K2 by K1 minus 1. So take K1 LCM, so it is K2 minus K1 now. K1 cancelled with K1, K2 minus K1 cancelled with K2 minus K1. So finally you can write CR max upon CA naught, that becomes equals to K2 by K1 raised to power minus K2 by K2 minus K1. Okay beta, is it okay to all of you? Very very easy. Now what to do next? See, final expression already you got. Here if you are using this minus sign reciprocal, then this you can write like K1 by K2. This one you can write like K1 by K2. So further moving, you can write CR max upon CA naught, that becomes equals to K1 by K2 and whole raised to power K2 upon K2 minus K1. Very very easy. So this is your final expression. Is it okay to all of you now? And my dear students, because the solution is very very large, so please remember it. You can't perform derivation in examination because it takes too much time. It takes too much time. Is it clear beta? Done? Crystal clear, sir? Confirm? Everyone please tell me beta. Everyone please confirm me. Crystal clear to all of you? Crystal clear, sir. Okay. So now because time is already up, so just I'm giving you for yes, consideration of yes as homework. वो आपको homework दे देते हैं. This one you need to remember. Okay. So now for yes, what to do re bhai for yes? We have one beautiful equation by equation number 3. By equation number 3, and that equation was plus dcs upon dt, and that equals to k2cr. यही तो था ना बेटा? This was your third equation now, my dear students. So clearly dcs and dt and cr, so you need to write this cr in terms of time t. So you can write this as dcs by dt, that becomes equals to k2, and in place of cr, oh my god, where are you cr? Where are you, sir? I am here. Oh, K1 CA naught by K2 by K1 CA naught. K1 CA naught by K2 minus K1, and here e raised to power minus K1 t minus e raised to power minus K2 t. यही था क्या बेटा? Please tell me. This was your equation? This was your equation? प्लीज कंपेयर कंपेयर कर लेना यार, उतारने में कुछ मिस्टेक हुआ हो तो बता देना. इफ ड्यूरिंग copying any mistake done by me, like minus written is plus here or plus written is minus here. Is it same? Please write same in comment section. If it is same, please write same in comment section. सभी का सेम है. So just perform this integration, put limit, and get your final expression. I will discuss in my next lecture. So this is your homework, beta. Solve this homework. We'll discuss in next lecture. Okay, beta. So tell me, beta, everything is crystal clear to all of you? No doubts at all? Everyone feeling comfortable in all topics discussed by me today? Tell me, everyone, please tell me. No doubts? No doubts, sir. Okay, very good, beta. Very good, very good. So everyone enjoyed today's lecture? मजा आया सभी को आज? So my dear students, this slide is for you again. Revision is the key for success. If you want rank 1, rank 100, any rank between or nearby these ranks, my dear students, don't forget to revise your notes every day. I must do my revision daily. 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 Definitely, but in this manner, you are going to join your dream job. Okay? Yes, sir. Enjoy it. Okay, beta. Me too. So still I am here till next 30 second to 1 minute. If any doubt, you can just write in comment section. Lecture will end in next 30 second to 1 minute. Thank you, sir. Shushmit, Sivatarun, you're all welcome, beta. You're all welcome. You know this year CRE, more than 15 marks asked. More than 15 marks. 15 नंबर से ज़्यादा आए थे. Exact I will show you with all questions. So this is very very important subject, beta. Very very important subject. Just by this CRE and non-technical plus mathematics, it is going to give you nearly 45 marks. Oh my god, only. Eh? And you are reading all things, and from CRE, it's my promise, beta, if you are going to follow your notes strongly, no one can take your one single mark. Okay, so चलो यहाँ पे एंड करते हैं, अगर कोई डाउट नहीं किसी को. सो ऑल द बेस्ट बेटा, टेक केयर, लव यू ऑल, वेरी वेरी हैप्पी गुड नाइट टू ऑल ऑफ यू. Mahalakshmi, I have doubt in question number 104 of MOSH. Just take a picture of that MOSH question, beta, and then send me on Telegram there. I will clear there on Telegram. Okay? Okay, beta Mahalakshmi? Okay, sir. Chalo. Take care, beta. You're welcome, beta. Shan Mukherjee Kya Das. Okay.